controlling and reporting power output is essential for all wheelchair propulsion research. These measurement techniques allow for the measurement and estimation of power output, which we can then apply to overground wheelchair propulsion, but also for measurements on the treadmill or on the ergometer. Wheelchair propulsion is a straining activity with a high risk of shoulder injury and inactivity, which is why we need proper research techniques. These methods are not only for daily wheelchair propulsion, but can also be used for wheelchair sports or during rehabilitation. Demonstrating the procedures will be Marika Leving, one of the postdocs in our team, and Klerk, one of the PhDs.
To perform a coast-down test, have the participants sit in an active position as standardized as possible, with the feet on the footrest, hands on the lap, and looking straight ahead.
The positioning of the participant in the wheelchair is crucial and should be reflective of the position during measurements.
To record the deceleration data using IMUs, attach one IMU to each wheel hub and one to the center of the chair under the seat. Write down which IMU is attached where and in what orientation for later reference. And use the NextGen IMU Synchronized Network Manager executable to turn on and connect the IMUs. To collect the time and velocity data, open the Tools tab, select Data Logger, and click Start. Then, briefly accelerate the wheelchair to a high velocity